probability combinations. So in these questions, when we're looking at how many ways can we combine something, the keyword is going to be choose or select. So how many ways can we select 5 men from a group of 15 to form a team? And the method that we'll be using for this then is NCOR. And we've seen NCOR before when we were doing our binomial expansion. And on your calculators, that button is going to... So for sharp, it will be your second function, number 5. And just above the number 5, you'll see NCOR. Where if it's Casio, what you'll be looking at is your shift function and the divide button. And above the divide button, you'll see NCOR. So there's going to be 4 different types of questions. We're going to select from all inclusion, exclusion, combinations from 2 different sets, and then at least 1. So if we look at the first one, if we're selecting from all, in how many ways can a committee of 5 be selected from 8? So we always write down what's N and what is OR. So N is the number that we're selecting from, so it's the full group, and OR is the number being selected. So we are selecting from 8 people, and we have to select 5. So what that means is that OR is, or 8, N is 8, because we're selecting from a total of 8 people, and OR is the number we are selecting, so we're making a committee of 5. So therefore that's just going to be 8 choose 5. So in other words, our NCOR is equal to 8 choose 5. And then 8 choose 5 on our calculator. So we would press 8, shift, and our divide button, 5 is equal to 56 if you're on your Casio. Or if you're on your Sharp, you would say 8, second function, 5, and then the number 5 again, and that would equal 56. So there are 56 ways of making a committee of 5 people from 8. So in type 2, we are looking at including or excluding something. So in this example here, we have an examination paper consists of 9 questions. So our total number of questions that we would be selecting from is 9. And we want to know, well, how many ways can we select 5 questions? So for the first part of the question, I'll call it part 1, our total number of questions is 9. The number we're selecting is 5. So our NCOR will equal 9 choose 5, which gives us a total number of ways of 126. So in other words, there's 126 ways of selecting 5 questions from 9 in an exam paper. The second part then puts a restriction in, and it says, well, what if question 1 is compulsory? Well, then how many ways can 5 questions can be now chosen? So because question 1 is compulsory, what that means is that the number that we have to select our questions from is now 8, because one of them is already gone. And the number of questions we have to do is 5, but we are told that question 1 is compulsory. So that means that one of them is already definitely done. So therefore that's 4. So our N choose OR is 8 choose 4, and 8 choose 4 is 70 ways. So if we look at another example of that, we have how many different selections of 5 letters can be made from the letters of the word chemistry. So if we have chemistry, well, that gives us 9 letters, and we want to select 5. So the number of letters we can pick from are 9. The number of letters we have to select are 5. So N choose OR is going to be 9 choose 5, and 9 choose 5 is 126 ways. So in other words, there's 126 ways of selecting 5 letters from the word chemistry. It then says, well, what happens if we have to make 5-letter selection where C is included in each of the selections? So C is included. So therefore, what that means now is that out of my letters, is that our total number of letters we're now selecting from is 8 because C is already included. And we're making a selection of 5 letters, but C is already included, so that means we have 4 left to select. So our N choose OR is going to be 8 choose 4, and 8 choose 4 is 70 ways. So there are 70 ways of selecting the 5 letters if C is always included. So in the next one, we're told how many 5-letter selections can be made if C is always included in that 5-letter selection and Y is always excluded from that 5-letter selection. So this time, if we look at the number of letters that we can choose from, well, if C is always included, I cross that out, and Y is always excluded, well, how many letters does that leave us with to select from? Well, if we have HEMIST and OR, that gives us then 7 letters to make our selection from. And we have to select 5 letters, but C is always included, so that means there are 4 left to pick. So then we write down our NCOR is going to be 7 choose 4, and 7 choose 4 is 35 ways. So type 3 is where we're choosing from 2 or more sets. So here we're asked to find the number of ways in which a panel of 4 men and 3 women can be chosen from 7 men and 5 women. So if we write down our men and our women, so we have 2 different categories. Well, the number of men is 7, the number of women is 5, and we have to select 4 men and we have to select 3 women. So in other words, what we're doing is we're selecting 4 men from 7 and we are selecting 3 women from 5. So if we get 7 choose 4, well, 7 choose 4 is 35 and 5 choose 3. So what we do is we actually multiply our answers. So we have 5 choose 3, which gives us 10. And therefore that means there are 350 ways that we can select 4 men from 7 and 3 women from 5. So this AND means multiplication. And if we saw OR, that would mean that we add. So if we do another example, we're asked in how many ways can a committee of 6 be formed from 5 teachers and 8 students? But we have a restriction here, and that's that there has to be more teachers than students on the committee. So if we look at the possibilities then, what can we do? Well, if we look at the teachers and the students, well, the total on our committee has to be 6. So it's a committee of 6. So how many different combinations can we have? Well, if we start with the maximum number of teachers, well, the maximum number of teachers that we can have is 5 because there are 5 teachers. And if we have to make a total of 6 on the committee, that means that we would have to have 1 student to make a total of 6. If I then had 4 teachers, I would have to have 2 students. If I had 3 teachers, I would have to have 3 students. If I had 2 teachers, I would have to have 4 students. And if I had 1 teacher, I would have to have 5 students. And if I had no teachers, I would have to have 6 students. However, if we look, the key word here was there had to be more teachers. So therefore, there's really only 2 different combinations. The rest of these are irrelevant because we have been told there has to be more teachers. So now we know our possibilities, let's work those out. So if we have 5 teachers, well, the number of teachers is 5. So therefore we're choosing 5 teachers from 5 and 1 student from 8. So and means we multiply. Or we could have 4 teachers from 5 teachers and 2 students from 8. So that would give us 5 choose, which is 1 times 8, choose 1, which is 8. So that would give us a total of 8 there. And then we have 5 choose 4, which is 5. And 8 choose 2, which is 28. So we have 5 times 28, which is 140. Now, because there are 2 different combinations, we can have 5 teachers and 1 student, or 4 teachers and 2 students. So because we have the or here, as stated on the last slide, what we would do is we add our 2 answers. So therefore the total number of ways of making a committee of 6 with more teachers is 148. So our last type is at least 1. So here we have in how many subsets, each containing 3 letters, can be made from the set A, B, C, D, E and F. So the total there is going to be 6 letters. So if we want to look at how many subsets can be made from 6, well, N is our total number of letters, so we have 6 letters. And or is how many we have to make, so we're making a subset of 3 letters. So therefore our N, choose or, would be 6 choose 3, and 6 choose 3 is 20 ways. So the total number of ways we can make a subset of 3 letters is 20. So then it says, well, how many subsets can be formed if each subset contains 1 vowel and 2 consonants? So that means if we look, we have vowels and consonants. So our number of vowels are 2 because we have A and E. And we have to select 1 vowel. And the number of consonants is B, C, D and F. So in other words 4. And we have to choose 2 consonants. So in other words it's going to be 1 vowel from 2 and, meaning multiply, 2 consonants from 4. So again this is our and. So vowels and consonants. So we have 2 choose 1, which is 2, multiplied by 4 choose 2, in other words 6. So that gives us a total of 12 ways. So we have 12 ways of getting a subset with 1 vowel and 2 consonants. So the next one says, well, how many subsets can be formed if each subset contains at least 1 vowel? So there's 2 ways in looking at this. You can get at least 1. Would mean that we have 1 vowel or 2 vowels, because I only have 2 vowels in my list, A and E. So they're the only 2 possibilities. So we could work out what it is to get 1 vowel, which would mean 1 vowel, 2 consonants, or 2 vowels, which would mean 2 vowels and 1 consonant. Or what we can do for at least 1 vowel is to get the total number of ways in which we can get our subset of 3 minus the total number of ways in which we would have no vowels, so our subset with no vowels. So we've already worked out our total. The total was 6 choose 3 with no restrictions. And then if we were getting no vowels, that would mean we would have to choose all of the consonants. So all of our consonants, well, there are 4 consonants, and if there were no vowels, then my subset would mean that there were 3 consonants. So I'd have 3 consonants from 4. So 6 choose 3 is 20, and 4 choose 3 is 4. So that means there are 16 ways of getting a subset of 3 with no vowels. Okay, so the ultimate question, where we have our group of friends. So here we have 9 friends, including Anne and Barry, wish to go to a show, but they only have 5 tickets. How many ways can the group of 5 be selected if both Anne and Barry are included? So if we have our total number of friends are 9, or is 5. So if there was no restrictions, it would just be 9 choose 5, which would be 126 ways. But if we include Anne and Barry, well, what that means now is that Anne and Barry have to definitely be picked. So the rest of the friends, well, there are 7 of them. And how many tickets have I left? Well, there are 5 available. Anne and Barry definitely have 2. Well, that means there are 3 tickets left. So that means that would be 3 selected from 7. And that would give us 35 ways if Anne and Barry are included. The second one says, well, either Anne or Barry are included, but definitely not both. They don't want to go together. So that means we can have 2 choices. We can have Anne is included. So if Anne is included, what that means is that we can have Anne or Barry, but not both. So we're still down to 7, and we have to look at the other 7 friends, not Anne or Barry. And then, well, how many tickets are available? Well, there's 5 tickets available, and if Anne gets one and Barry doesn't, well, that means there are 4 left to give out. Or we could have Barry included and Anne not included, in which case, well, we're still looking at the other 7 friends to give a ticket to, and we still have 4 tickets left to give because Barry's getting one and Anne isn't. So there are still 4 left. And the or means that we are going to add the 2 answers. So in other words, we're going to have 7 choose 4 plus 7 choose 4. So 7 choose 4 is 35. So in other words, that's going to be 35 times 2, or in other words, 35 plus 35. So in other words, there are 70 ways where either Anne or Barry are included, but not both. Okay, so the last one then says, well, in how many ways can the group of 5 be selected, given that at least one of Anne, Barry and Claire must be included? So what this means is that if we have at least one included of Anne, Barry and Claire, we could have Anne included, or we could have Anne and Barry included, or we could have Anne, Barry and Claire included, or any combination of those. So the easiest way to do this for our at least one is to look at the total minus none of them are included. So our total, I showed you at the start, was 9 choose 5. So in other words, selecting 5 from a total of 9, minus none included. So if Anne, Barry and Claire are not included, that means we have a total of 6 other people to look at giving the ticket to. And if Anne, Barry and Claire are not included, that means they're not getting the ticket, and therefore that means there are still 5 tickets available. So that means we're going to have 5 choose 6. So 9 choose 5 is 126 minus 6 choose 5, which is 6. And therefore that gives us 120 ways in total for at least one of them to be included. So if we go to page 53 in your books, and you're going to do questions 7, 8, 9, 10. And you're going to do question 14 and 22.